The basic building blocks of matter are the chemical elements. Here's a list of several of the most common elements and their symbols. You will be responsible for knowing both the name and corresponding symbol, and I believe that as we go through the next several weeks, we'll use these quite often, so it shouldn't be too much of an onerous task. However, if you feel the need to make some flashcards, you can do that. There's several online quizzing sites that you can use. You could create a Quizlet, any of those things to help you learn the symbols and corresponding names for these elements. Now, we've been building up the kind of our repertoire, number of elements for a long time, ever since we thought that there were only 4: water, earth, air, and fire. Obviously, we've expanded and included quite a few more varieties of different elements. Obviously, water, earth, air, and fire aren't really elements. So it became, at some point in the 1700s, necessary, 1800s, necessary to try and organize these elements. And so several chemists tried to figure out a way that these elements might fit together. And they were able to recognize certain patterns in the properties of the elements. So they could put them together into groups with similar properties, and they noticed kind of trends in them. The person who is given credit as being the father of the table of the elements is Dmitry Mendeleev. So Dmitry Mendeleev was obviously studying the properties of the elements, putting them into places, but one of the critical advantages that he had in his model was that he was able to predict the properties of 2 missing elements, one that had a relative mass of 68 and one that had a relative mass of 70. Based on the way that he had them organized, he felt that there were elements missing at those 2 places. And he was able to predict the properties that those elements might have. And sure enough, after a few years, we discovered those elements were discovered, and they corresponded very closely to the properties that he predicted for them. Our current periodic table looks quite different from his original one, although the elements that he had at that time are basically organized in the same way, just oriented slightly differently. Here you see several different colors corresponding to different groups of elements, and we'll talk more about those. For now, probably the most important distinction that you need to have for these, which you've probably already been informed of, is that toward the left side of this jagged line here, so left of that we have what are considered metals, and to the right of that we have what are considered nonmetals. Elements that are along that jagged line are going to have properties of both metals and nonmetals, so they're called semimetals. So they're kind of like a blend of a metal and nonmetal. In class, one of the activities that we'll do is we'll make a list of properties of metals and properties of nonmetals. Here's an extended version of the periodic table. You'll understand this a little bit better when we get into how the electrons are organized around the outside of the nucleus in an atom. So the way that this table looks will become a little bit more understandable, and we'll get a better grasp of it at that point. Here we have some of the natural states of the elements. If you look at the elements that we have, most of them are solids at room temperature and room pressure. Obviously, solids can change to liquids if you increase the temperature. Gases can change back into liquids if you lower the temperature. There are only 2 liquid elements at room temperature. Those are mercury, which is a metal, so it's a liquid metal at room temperature, and bromine, which is a nonmetal. So the 2 of those are the only 2 elements that are liquids at room temperature, although the element gallium has a very low melting point. So if you were to put gallium in your hand, it would melt in your hand. Another property of the elements that we should be aware of is that they can have their structure, the way the atoms of an element are bonded together, can create substances with very different properties. Up in the upper right-hand corner, we see a diamond. And obviously, a diamond is a very hard solid at room temperature. Now, that picture there shows the way the atoms of carbon are bonded together or connected to make a diamond. Right next to it, we have a picture of how the atoms are bonded together to make graphite. So again, same type of atoms, carbon atoms, but the way that they're held together creates a substance with a very, very different properties. And then one of the more interesting developments in chemistry several years ago is the Buckminster fullerene. And this is yet another structure of a carbon, carbon structure with the carbon atoms bonded slightly differently. And that's something that hasn't found any real practical uses yet, but I'm sure that will change. They'll find ways to modify and adapt this. The term that's used for these different forms are allotropes. All right, so these are 3 different allotropes of carbon. So the term allotrope is important for us to understand what that means. And the last thing for right now, in terms of the elements that we want to get a handle on right away, is that several of the elements are found as diatomic substances, meaning that under normal conditions, 2 atoms are bonded together to make a molecule of that substance. So hydrogen, for instance, you would never find hydrogen atoms by themselves under normal situations. There would always be hydrogen molecules, H2. Same thing with nitrogen. You wouldn't find nitrogen atoms floating around in the air. You find nitrogen molecules, N2, so 2 nitrogen atoms bonded together. If we go back and take a look at the periodic table, you'll notice that the elements that are diatomic make kind of a 7. So we've got nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So it's kind of like a 7 with those 6 elements and then hydrogen. So however you need to remember that, but that's one of the things that will show up over and over again this year is that those 7 elements occur as diatomic species. All right, so again, work on memorizing the symbols for these elements, and we'll do some activities in class that will help you along the way with that.